Today is a very interesting day for Epic. We are visiting QiOVA. These are very difficult times, very strange times in which real company visits are perhaps not the best way to proceed, so we do it virtually. Today I am visiting QiOVA in beautiful Saint-Etienne. I have the honor to have with me today the CEO of QiOVA, Florent Thibault. Florent, how are you doing today?
Doing fine. Hi, Jose. Hi, everyone watching. It's really good to be here. And so we'll be testing with you the first virtual visit with Epic. So really glad to be here. Thanks.
First of all, before all that, I have to congratulate you. You are the Epic member number 600. You have reached this important milestone, and we couldn't have done it better than with a very innovative company, which is QiOVA. So for those of you who don't know QiOVA, you are missing out. QiOVA is a key company when it comes to beam shaping. They actually can program any beam shape that you want and have it out of any laser at any wavelength, at any pulse rate, and for any kind of power. This is the innovative concept that QiOVA is putting in the market. So today we are in Saint-Etienne. We are in a key location for laser manufacturing, and we have the CEO with us. Florent, what do you say about QiOVA? What is the story of QiOVA? When did it get started?
I can tell you, thanks for the introduction. So QiOVA was founded in 2011 by a couple of PhD people. There was Sébastien Landon, Benjamin Dessert. And it was originally a business model of application. So we are originally application expert, laser application expert. So you can see a few reminds from the past here. And over the years, we've been developing this innovation that is based on specialized modulation and developing this expertise of dynamic laser beam shaping. And I think, with no discussion, the best award we've been receiving so far is, without any discussion, the 600 members of Epic here. And once again, we're really proud to be part of the biggest photonic association in the world. Right now, the idea for us to develop industrial tools and develop the next generation of tools for the industry of the future. So a laser is part of the production tools of the future. It has to be productive. It has to be flexible. It has to consume less resources. And this is exactly what we're doing here.
What we have seen in the last years is that the laser technologies have developed like crazy. This is over the last 20 years. Actually, I believe that when the telecom bubble exploded, many companies who were developing photonics, they realized that the laser-based manufacturing was the place to go. So we have fantastic lasers, but to satisfy the needs of end users, the key thing to solve is the right beam shape. So how did you think about that? What was your idea about programming a beam shape, bringing digital world into a very analog, traditionally analog way of manufacturing?
Yeah, it starts everything with the laser as a production tool. It seems obvious to us, Jose, because we're part of this photonics world. But most of the people outside first don't know about this. So first, the laser is a great tool, non-contact, eco-friendly, and consuming much less than the traditional resources. So first, it's a great tool. But then you have to think about what's coming next. And the next concepts for manufacturing is that you need to only produce what you want to produce. There's a very good example with the additive manufacturing. Instead of having a very big part of material and removing what you don't need, you need to be in the thinking where you only create what you need. And again, it's very much eco-friendly. And we have the same idea with the laser. So lasers are developing today a lot of powers, but not a lot of people are really using that kind of powers. And so you're losing out a lot of energy and a lot of possibility. And so with the programmable beam shaping, you'll be able to use a lot of different beams at once. So you will get faster, more productive. You will take the best out of your laser sources. And also you want to digitize manufacturing. You want everything to be fully integrated. And that's why the software comes into play. So you will have, Sébastien, our technical director, will explain you a bit better. So we're developing a hardware component. You need that hardware in production. But then the idea is that with the software, you will be creating the different tools. So you will have like a Swiss knife of laser tools that you will be able to program and adapt to your needs.
I can't wait to see the thing in action.
You want me to show?
Yeah,
We
let's
can
go.
to lab,
I
right?
cannot wait anymore. Let's go. Let's
So
see. Let's
let's
see
go
what
to
you
the lab.
have
We'll
what
be,
you work to the lab. How many people are working at QiOVA these days?
so these days we're only 5 people. We're preparing a Series A round so that we can develop and expand in the coming years. Our plan is to be 15 to 20 people in the next 5 years. But let me just knock at the door. Johan?
This is the same kind of spirit of a normal visit. We knock at the door and the person is there. And
I'm gonna introduce to Johan. He's our laser expert. Just 1 second. Hi. So this is Johan. Magical hands.
Hello,
We're,
Johan, laser expert at QiOVA. Hi, I'm Jose from Epic.
we're gonna show you basically how the technology works. So the idea, we're gonna project on the wall the laser beam. So this is your laser beam that you would use for processing, but we made a display so that it's visible to everyone on the video. And you will see we've developed a software that allows you to create dynamically live or create codes. This is for marking application, or create patterns for micro machining application. And you can do this at the tip of the finger, and it's all dynamically configurable. So you can see we have a little something on the wall.
Okay. It is quite impressive. Thank you so much for this. This is the Epic member number 600, and what we are seeing in front of us is dynamic beam shaping of our logo 600 member of Epic logo. This is great. This is now when you see Photonics in action. This is really fantastic. Well, I have no words to describe how thankful I am on behalf of Epic, on behalf of the other 599 plus members. Thank you so much.
This is the software. So that's the software. It's called Beamforce. So you will see we have a first. What we want to do here is to make this kind of technology accessible to everyone. Okay, so this is our stuff, and we want our customer to be able to create simply what they want to do. So, for instance, we have this tool that is called Pixmap. You see, you have a matrix here, and Johan is going to change the size of the matrix. And you see, at the same time, you have the interface that's showing what will be your beam pattern like this. So, if you reactivate this, you will see that on the wall.
Mm-hmm.
I hope everybody can see. It's not always easy. It's gonna change. Oh, you've seen?
Yes. Yeah.
So we change to the new type of matrix. And so probably you want to change a little bit that pattern. So Johan is gonna click on a few dots that he wants them to be removed like this. So it's click based. You're creating a pattern in live. Okay, when you're done with that, you can simply apply, and you will see the change on the wall. There's a little more difficult to see, but there's a few dots that are missing out.
Yeah.
And even more difficult for those who have great eyes, you can also tune. That's for micro machining application is very useful. You can also tune independently each of the beams. So you will see the change of color on the pattern. That means we are controlling individually the energy content in each of the beams. So you see all these different colors.
Oh wow.
It's going to be a little hard to see on the wall because we're having a green light. But you can trust me, this is what is happening. And so this is the way you're optimizing your process using your beam pattern. You can do this live, and then you can converge to the right pattern. Simply.
You can fully control the intensity of any of those. We can call them pixels, but then you can make any pattern. And this is what I call a 3D pattern. You have the X, Y, and the Z axis is the power. It's a 3D beam shaping programmable. Oh my God.
And that's only one tool, Jose. We're going to serialize you. I told you just before the interview. So we have a lot of application that is about marking, traceability, serialization. Essentially, when you work with all these beams in parallel, you can go much faster. When we want to mark a code, you don't have to mark one of the dots one after each other like you do. We are printing everything at the same time. We called it stem marking, patented. And that means that you need one pulse to mark one code. And I can tell you, you go very, very fast. So we have another generator here. So we're going to serialize you, Jose, okay?
Jose, should I be scared? I'm very...
you can trust. You can trust. No worry.
Let's go for that. This is the time in which I'm going to be serialized.
Serializing Jose. Okay, and then we create here automatically. This is the data matrix that is Jose for the one. And then we will be applying this so that you can shoot. You shoot with one pulse and you get that on your material if it's properly set. Can you see that, Jose?
I can see the pattern, yes. People have done many things to me in the past. I never been serialized.
Yeah,
so
but I mean,
very curious about this.
You need to have one. So we can make Jose Pozzo number 2. So we're going to do this by hand. And then, of course, if you're on the production line and you've got all this product going very fast, you need to start sequence of this. And this is what we're going to show you as well. So this is Jose Pozzo number 2. And then we're producing a lot of this because it's a very, high potential product. Everyone wants one. So we're starting the sequence of serialization. So we will be sure to know where is every Jose in the field. We will be sure to manage target records. And we can also add some anti-counterfeiting information because everyone wants to copy our products. And we're going to also read that just to show that we're not faking. Can you read what's on the wall? You want, please? Okay, so what is reading the stuff? Jose Pozzo.
Oh, wow.
Damn, it's working.
I've been serialized. Fantastic. Wow, that's it's the first time ever in my life that something like this has happened, and I'm extremely happy, and somehow I feel very strange. I don't know how this was actually coming to your mind, but thank you so much for that, and thank you for the continuous innovation that QiOVA is bringing for the laser community. As you know very well, we have now all the different technologies for laser-based manufacturing, from the high-power lasers to the optics to the beam shaping, and we are doing constantly try to find new end users for the metal, for the glass processing, where laser-based material processing is making a big difference. What kind of problems are you trying to solve with this idea that now the user of the laser can dynamically and at any time define the beam shape that he can use?
So there are basically, as you were introducing here, we operate in the material processing industrial world only. Right now, focusing on marking, micromachining. So we've seen some marking example. I'll show you a little bit what it looks like for micromachining right after. What we're trying to solve is, for marking, we want to offer the new tools to enable traceability. Give a product identification solution in very high volume production. That's one bottleneck in industry today. You cannot mark the very small parts, for instance. We can mark these data matrix down to 500, 300 micron, perfectly readable. And you also have the possibility to add anti-counterfeiting features in that. And there's a lot of brands around the world that are really craving for that kind of solution. We can mark the glass. We can mark any kind of material if you choose the right laser. So this is what we're trying to solve for the marking of these people. And a big of it is the throughput to the parallelization. You see, release is ID. Usually, you use one laser beam. This is a big limitation. We want to use 10, 20, 50 at the same time. And you go 50 times faster. It's pretty easy as math. Let me just show you what we can do also for micromachining. This is the same idea. Specifically for short pulse laser, you cannot put too much energy on your sample. Otherwise, you're damaging quality. So you happen to be operating at 10, 15% of a very expensive piece of equipment, which is a waste, totally. So when you work in 10%, we say, hey, why not use 10 bits in parallel? And you can try and create them dynamically, and it looks like this. This is a commercial laser. And here on top, you can see it's connected to our product. Here, you have the digital beam shaping. And once you've shaped your beam, it's being delivered by the scanner here. So you're essentially conserving the usual part of your machines, simply adding this part, generally less than 10% of your equipment, and you get 500% productivity. What can you do with that? You will parallelize simply your process. It's maybe a little difficult to see here, but you see, we've been doing some trepanning action here.
Mm-hmm.
And
we can see this.
You can see it a little difficult on my little screen, but you see, you can have these 5, 4, 10, 9. I mean, what you want. You can drill everything in parallel with the same quality and making full use of your equipment, simply.
Fantastic. It's indeed a very innovative company. I think right now, for many applications from micro machining to macro machining, it really puts you ahead in the kind of flexibility you give to users.
Yes.
The present of the company is very clear. You already have the solution in your hands. You already said that you are planning to grow the company in the coming 5 years. Tell me about your preferred future. Tell me how you see the company when I come again virtually in 5 years to visit you or in person in Saint-Etienne. What will I see differently?
We have picture actually. We have an idea of the industrial future that is not the very, not this huge industry vertically integrated. Innovation is going much too fast today. We see us as a contributor, a very high value added component in all these high mechanism that is connected with a high level of cooperation. That's why we're trying to develop here in QiOVA, focusing on our core expertise, digital beam shaping solution, providing the best product to our customer to enable them, and cooperating a lot with our peers in the photonics industry so that we can benefit from their expertise and create new innovation through the partnership.
For me, there are really two big markets that are going to open up for you. One of them is clearly the huge developments that we are seeing in glass processing. That's growing dramatically. Only first because it was initially driven by the companies in the large volume sector, the consumer electronics companies. So companies like Samsung, like Apple were driving this innovation, and later we have seen many applications in other niche markets. So now we have to translate what was done in a kind of Ford style, in a kind of repetitive style, to make customized products. Customization enters, and now is when you will excel. Is that right?
Exactly. I think you have a workshop on this, by the way, in a few days, right?
Yeah, that's right. Yeah. In a couple of weeks.
Glass is really a material for laser. It's very difficult to work with mechanical tool.
Where are you taking me now?
Where I'm moving you to the meeting room with a little showroom.
Fantastic. Let's have a coffee. Look at the mug that I have for my coffee.
We just bought one.
This is my coffee. I will put it here in my mug.
So you see, this is our product. You've seen that a little bit. This is called Bulk One, and this is the module. Okay, we can probably show you one real one. It's over there. You see, it looks like this. You have the laser input here and the laser output at the bottom, a little bit like you would do with a scanner. And so you have these different application fields and benefits. Very high speed. You see here, there was testing we made with people who are printing banknotes, and we are marking codes at 1,000 codes per second. Okay? 1,000 2D codes per second. Of course, they cannot be unique code. This is for lot marking, kind of lot marking. But this is the kind of speed you can reach with the stem marking, 1,000 codes per second.
And that's, of course, a market that you have seen growing like crazy on the not only on the currency, but I can see now that you're talking about anti-counterfeiting as well.
Right. We move to the anti-counterfeiting features. And it's a little difficult. Of course, everything here is very small, so it's a little bit difficult for me to show you live, but we will see some pictures. So we got these people this is pure gold. And you see on this little cross here, so it's a few millimeter, we are able to mark here all that stuff. You see, you can do characters, and you can see this. This is an Aztec code. It's called that one with a square in the middle. And he has some security features inside. So it's a kind of code that is hidden in the logo. And it's possible because as we're printing all the dots together with all these beams, you can create some recipe by superimposing dots, for instance. This is all customer recipe. This is not our. Exactly like you were saying, Jose, we provide a tool, and then customer can put their imagination in their process there. We're only here to provide the right tool for that. You have here an example of parallel marking. So you see, this is one customer that's producing this kind of PET tubes, and they had a laser marking step. When you have to do 10 lines like this, and that was the bottleneck for the process. Very simple. Instead of doing 10 times 1 lines, we're doing 1 time 10 lines. Done. And there's no bottleneck anymore in the fabrication.
What we have seen in the laser marking business is, well, of course, everybody knows Trumpf is actually doing laser marking for medical tweezers to make sure that they had the right code for every doctor to be able to use them for the right environment. That's a market that is growing like crazy because now with your technology, you can actually customize to the extreme. You actually can print a set of QR codes in which you can any company would know the kind of tweezers that any medical doctor can use by just basically scanning with the mobile phone and say, okay, this one is the one that you need to use to treat that particular patient that has COVID-19 or that has something that definitely needs to be fully sterilized after. We have seen quite a huge... I'm going to put this politically correct. We have seen that fake drugs is a big problem currently. Is that something that you want to target, the market of authentication of drugs by putting a stamp that nobody can copy unless they have the same laser and the same software and the QiOVA tool with the right wavelength and power?
You're spot on again, Jose. I mean, I was presenting at eMicronora a couple of days ago, and you are exactly putting the deal. That was the introduction. Like fake drugs, they're killing 100,000 of people every year. I mean, it's the worst counterfeiting market in the world. It's more than marijuana, prostitution, everything you like. So it's really a very big deal. It's global. It's happening more in the developing countries than in our developed countries, but it's still happening. And this is definitely part of the challenges that we would like to raise up to with the technology, right? It's not only about making money. If you can also save life, that's definitely something we want to go for. You know, we've been talking a lot about multiple beams, going faster, smaller, authentication features. But when we're talking about the future as well, we've been saying going beyond the limitation of the Gaussian beam. So one limitation is the fact you have one output of the laser. But just as a little snap into the future, just want to show you that we can also, with the same hardware, we can generate any kind of beam that you want. It can be a top hat square, a top hat round, an airy beam, a bezel beam, and that's part of the Swiss knife of industrial tools of the future. So just to end our little tour, thank you again to everyone who's been watching until the end of the video and look at what the future is looking like. So this is top hat round, this is top hat square, and this is a donut. And basically you can do everything you want with the same device here and a laser. That's here.
It is really a strange time in this world. It is really a time in which we really cannot travel as much as we want. It is a time in which we really have to make the best use of the online world. And this is what we did today. I went to Saint-Etienne and I visited QiOVA. Thank you very much, Florent Thibault, CEO of this huge, innovative company. And the next time, take care.